Morning, everyone.
Good morning.
Good morning, sir.
So,
Good
students,
morning,
let's
sir.
start with a new chapter today. Let's start with friction. What is Newton's laws with friction? We have been dealing with ideal cases where there is no friction at all. All surfaces are smooth. But now let's start with friction. Students, we have got a block or some object on a surface which is not smooth as before, but it's rough. Alright, as in a practical scenario, it's rough. Now, what I do, I apply some force on it, and let's say I've got a block like this. I'm applying some force with my hand on this object. Applying some force, but I see the object is not moving. I applied a very little force with the hand. I feel the force because I'm applying the force on this object, but I see the object is not moving.
Sir, it's not visible.
Yeah, yeah, what's the problem? All right. So I see I applied some force, but I still observe that the particle is not moving, the object is not moving, the book is not moving. But I applied a force. If there is net force on the block and the particle is at rest, it is supposed to accelerate. But I see the object is not moving at all. That means there is the net force on the body is zero, which implies that there is some other force which is acting on the block, which is counterbalancing this force, applied force. All right. That force is a force of friction between the block and the table and the surface, which is towards left, because it has to counterbalance this force, applied force, and that will be equal in magnitude and towards left. That means if I apply a force F towards right, the friction is counterbalancing this force by self-adjusting itself. If I increase the force a bit, I still see that the body is not moving. All right. I applied some force initially, it's not moving, but I apply even a little more force. I observe that the body is still not moving. That means it is again being counterbalanced by the friction. This is my applied force F. It's now increased. I increase this force. I further increase this force. If I still see it's not moving, what it implies is it's being counterbalanced by the friction. That means friction is self-adjusting here. Friction is increasing as my applied force is increasing. But why I say friction is opposite direction and there is friction happening? Because if there were only force F applied, if there were net force on it, the body would move. But I observe that body is not moving at all, which implies there is net force on the body is zero, which implies that my applied force is being counterbalanced by some force, and that is friction. All right. So these are the experimental observations which we observe when I perform the experiment. All I'm doing is applying force. I see the object is not moving, which implies there is net force on the body is zero. which means my applied force is being counterbalanced by some force, and that force is friction. And I see if I increase the force a bit, I still see the object is not moving, which implies my friction is increased. My force is counterbalanced by some other force, which is friction. Because my force is increased, my friction is also supposed to increase and equal to the applied force. If I further increase this force, my friction is further increased and it's being counterbalanced. But what is observed is if I go on increasing the force, at some point of time, at some point, it will start moving, right? It will start moving. That means for some particular value of force, when I increase the force further, my friction did not counterbalance the force. I further increase the force. I observe the friction is not counterbalancing the force, and friction is observed to be constant. How do I observe it to be constant? I measure the acceleration of the particle and see that, and I calculate, reverse calculate the friction. I observe that the friction coming into picture is constant. Here, the friction was going on increasing as long as the body was not moving. So this part of friction, this kind of friction is called static friction. And once the body starts moving, I observe the friction is constant in magnitude and direction and opposite to the direction of velocity. This is kinetic friction. So we've got static friction and kinetic friction or dynamic friction. Static friction is as long as the body is not moving or it has a tendency to move. There is no relative motion between the body and the surface. Static friction comes into picture. And static friction is self-adjusting. That's what is observed. But once the body starts moving, my friction which is coming to picture is constant in magnitude and direction. It is opposite direction of relative velocity between the bodies in contact, surfaces in contact, and it is constant in magnitude. That's what is observed. I further increase the force, my friction remains constant. All right, this is the experimental observation. Now, if I plot a graph for this one, this is applied force F, this is friction force on the block. This is how it's observed. As I go on increasing F, my external force is increased, my friction is equal to the external force, equal in magnitude but in opposite in direction, counterbalancing the external force. That's why this angle is 45 degrees. This goes on increasing to a certain value, which is Fs, limiting friction, Fl. Once I reach this limiting value Fl, if I further increase the force a little, plus delta, this F plus very small value delta, my frictional force drops to Fk. And the particle suddenly accelerates with a jerk. All right, that's why we have a kink here in the Fx graph, friction versus applied force graph. It is not a smooth graph here. There's a kink here. All right. And why do I say there's a kink here? Because the object suddenly starts with a jerk here when the force F is suddenly increased, slightly increased, not suddenly increased, slightly increased, and it is little more than Fl. If it is little more than Fl, like very small amount delta, it is observed that particle starts with a jerk and accelerates. And to maintain uniform motion after that, my required force is not F but little less than F. Not Fl but little less than Fl, which is Fk. So this is Fk, this is Fl. Any doubts so far, students? All right. Presuming you don't have a doubt. All right. It is observed now. I'll just quickly repeat in a minute. I have a block on which I applied a force. It is observed the body did not move, which implies the net force on the body is zero, which implies that my applied force is counterbalanced by friction, some force, which I call friction. Now, if I slightly increase this force by small amount, I observe the body is still not moving. That means my force of applied force is still counterbalanced by the friction, which is also increased in magnitude but opposite in direction because counterbalanced. That means I can conclude that my friction is self-adjusting. But what kind of friction is self-adjusting? As long as the body is not moving, as long as the body is static, that is static friction is self-adjusting. I increase the force or I change my force and the body is not moving, I conclude that the friction is self-adjusting itself to counterbalance the applied force. It will self-adjust to a certain limit Fl, beyond which if I increase by delta, very small amount delta, particle will start with a small jerk, which implies that my applied friction, friction acting is less than the Fl, which is Fk. If I further increase the force, it is found that Fk is constant. All right, so this is the kinetic scenario. This is a scenario when the particle is moving. This is a scenario when the particle is not moving. So static friction is self-adjusting and counterbalances the external force applied, whereas kinetic friction is constant in magnitude and opposite to the relative motion between the surfaces. This statement is very important. Kinetic friction is opposite to the direction of relative motion between the surfaces. Kinetic friction will oppose relative motion. All right, it doesn't mean that it opposes motion, it opposes relative motion. Let's talk about what I mean by that. That brings us to the next scenario. All right, graph of this one is friction versus applied force. Initially makes it's a linear graph making an angle of 45 degrees with the x-axis. Slope is 1. It increases to value of Fl, suddenly drops to a value of Fk, which is little less than Fl, and remains constant. All right. Now look at this. I apply a force of 2 Newton. All right. I observe the particle is not moving. So what is the friction on the block? I applied a force of 2 Newton. I observe the particle is not moving, which implies net force on the particle is 0. That means there is some force which is counterbalancing my 2 Newton, which is applied force, and that is friction. So what is the friction on the block?
2.
2 Newton.
Same,
Right.
sir.
Same, right. That's right. So same 2 Newton. And friction is shown parallel to the surface. So every real force has got an action and reaction pair. If this is action, its reaction is on the surface, which is towards right. So reaction of friction force on the block, which is towards left, is towards right on the table or on the surface. So these two forces form a pair, action reaction pair. One acting on the block, the other acting on the table. Action reaction pair always act on two different bodies. They do not act on the same body. All right, that doesn't make sense if I say they act on the same body. If they act on the same body, net force becomes 0. All right, that doesn't make sense at all. Action reaction pair always act on two different bodies. If 2 Newton is acting on the friction is acting on the upper block block towards left, its reaction is on the table is towards right, or on the surface is towards right. If I say there is 3 Newton force, and I observe that the particle is still not moving. So what is the friction now? Three Newton. Because particle is not moving, my force is to be counterbalanced by this force. So this force has to be 3 Newton. But then I observe, if I apply 4 Newton, particle suddenly starts moving. All right, and it accelerates towards right with an acceleration A. acquires a velocity v naught. In that case, what is observed is friction, which is Fk, which is constant in magnitude, and opposite to the relative velocity between the surfaces. If velocity of body m naught is towards right, friction is towards left. Kinetic friction is easy to handle. Static friction is not easy to handle. Remember this. You'll experience this when we do some problems. Kinetic friction is easy to handle in a sense. Direction of kinetic friction is very easy to figure out. And how do I do that? If velocity of the block with respect to the surface is towards right, kinetic friction is towards left. If the velocity is towards left, kinetic friction is towards right. It opposes the relative motion between the particles. All right, this is one thing. Now we'll come back to that in a minute. We'll come back to that relative motion in a minute. But right now, it is also observed that friction is independent of the contact area. Independent of area of contact, and it's proportional to the normal reaction experienced by the block. All right, so FL, the limiting friction, is independent of the area, and FL, limiting friction, is proportional to the normal reaction. That means if I push this block further and apply this force 5 Newton, and I observe that the particle is still not moving. Before it was moving at 4 Newton itself, but now even if I apply 5 Newtons of force, particle doesn't move. That means it is observed that normal reaction is increased, my limiting value is increased. If limiting value is increased, my self-adjusting force now can adjust to a value of Fl, which is greater than before. If it was adjusting only to a value of 3 Newton before, it is observed that it is able to adjust itself to a value which is greater than 3 Newton now. What resulted in this change? Normal reaction is the difference. If I increase the normal reaction, my limiting value is increased, which implies net force now applied can be more than before for the particle not to move, for the particle still tending to move, for the particle still to remain at rest. Just a second, students. Yeah, right. Able to hear me, right?
Yes, sir.
All right. Okay. So it is observed that it's proportional to normal reaction. If I remove this proportionality sign, I'll get a proportionality constant which is mu s. And it is observed that Fk is proportional to normal reaction again, which is equal to mu k into n. Experimentally observed that mu s is greater than or equal to mu k. Usually it's greater than mu k. If not mentioned, we presume that mu s is equal to mu k in problems. If I just say there is friction on the block, if I don't mention what is mu s and mu k separately, if I just say the value of mu is this, then that means mu s is equal to mu k. If mentioned specifically that mu s is different than mu k, then you consider mu s to be different than mu k in problems. If not mentioned, we consider mu s to be equal to mu k. All right. And value of mu can be between 0 to infinity. This is what experimentally observed. So these are all experimental results that friction is self-adjusting, static friction is self-adjusting to a limit which is Fl, which is proportional to n, proportionality constant being mu s. Once it crosses the limiting value, there is a kinetic friction comes into picture, which is again a constant in magnitude and equal to mu k into n. All right, both are proportional to n, but proportionality constants are different for mu s and mu k. And they are different because of the reasons at atomic level. All right, which we are not going to venture into. All right, now let's talk of kinetic friction. Kinetic friction now, let's say this particle is moving with 4 meters per second. And there is a surface, flank, which is not moving. All right. So friction on the block will be kinetic or static. The moment you see the particle is moving, the friction is going to be kinetic. Moving in a sense, moving with respect to the surface in contact. All right. So these two surfaces are in contact, and this is moving with respect to this surface with velocity of 4 meters per second. So that means the kinetic friction is going to be kinetic and towards left. It is independent of velocity, but now even if it is moving with 3 meters per second, my friction is towards left of the same magnitude mu k into n. All that matters is the particle is moving or not. If the particle is found to be moving, then kinetic friction is opposite to the direction of relative motion. Motion of this block with respect to the plank is towards right, friction is towards left. If I stand on this plank, I see the particle going towards right, then the friction is towards left. But now let us say this block is not moving with respect to ground, but the plank is moving with a velocity of some v naught. Then when I stand on this plank, I observe that the particle is moving towards left. I observe that the particle is moving towards left. So friction will act on particle towards right. Friction, kinetic friction, always opposes the relative motion. This is moving towards left. It will try to reduce its velocity with respect to the plank. It will try to bring it to rest with respect to the surface in contact. Kinetic friction will always is easy to handle one thing. Kinetic friction will always try to oppose the relative motion between the surfaces. It will try to bring the surfaces in contact at rest. I mean, it will try to bring the body to rest with respect to the surface in contact. That means if I stand on this plank, this body it seems to move towards left with velocity v naught. Obviously, right? Velocity of this with respect to the plank is towards left. Friction will act towards right. Now velocity is 2v naught. Then velocity of this with respect to the plank is 2v naught towards left. Friction is again the same thing, fk. That doesn't change. All right, it is independent of the relative velocity, but it is opposite to relative velocity. So my friction fk is equal to mu times n magnitude wise, but direction is minus vr cap. Understand this equation properly. There were questions simply based on this equation before. All right, we'll handle that question now. There were questions before previously in mains, Neet and advanced simply based on this equation. Let's understand this equation carefully, properly. I've got kinetic friction, magnitude is mu into n, but direction is opposite to the relative velocity and independent of relative velocity. See, it depends on the VR cap. It doesn't depend on VR bar. It doesn't depend on VR relative velocity. It depends only on the direction of relative velocity. So VR cap decides what is the direction of friction, and it is opposite to that. That's why minus VR cap. All right. I hope you understand this. Look at this. This particle is moving towards left. Friction is towards right. If the particle is moving towards right with respect to the plank, friction is towards left. But now, let us say this particle is moving towards right with velocity of 2v naught, and the plank is moving towards right with velocity of v naught. Now, what do you think the direction of friction is? Magnitude is same again, mu into n, where n is the normal reaction experienced by the block, but direction is minus vr cap. Let us see what the vr cap says. Vr cap is velocity of block with respect to the plank. So velocity of block is 2v naught towards right, 2v naught I cap, minus plank, v naught I cap, which is v naught I cap. So which is towards right. It is independent of this magnitude. It only depends on the direction in which the relative velocity is acting. So relative velocity is towards the right of the block with respect to the plank is towards right. Friction will be towards left. Simple. If this were 2v naught and this were v naught, now what would happen? If I stand on this plank and observe the block, velocity of block is v naught I cap minus 2 v naught I cap, which is minus v naught I cap. So velocity of the block with respect to the plank is minus v naught I cap, which is towards left. That means if I stand on the plank and observe this particle, this particle will seem to move towards left with velocity v naught. Doesn't matter with what velocity it seems to go. But what matters is it moving towards left or towards right? If the particle seems to move towards left with some velocity, the friction is towards right. If the particle seems to go towards right with respect to the surface, then friction is towards left. All right. Okay, so I'll give you a scenario. You tell me what is the friction between the surfaces. Two meters per second, 1 meter per second. This is rough. This is rough. So there is kinetic friction now between these two surfaces. This is surface, rigid surface. It is not moving. This is moving with 1 meter per second. Block A is moving with 1 meter per second. Block B is moving with 2 meters per second with respect to ground. So how do I measure how do I decide what is the direction of kinetic friction? I stand on the surface. I observe the block. I observe in which direction is the block moving. So this block is moving towards right. Friction is towards left. Kinetic friction is towards left. To decide the direction of friction on this block, I stand on the surface on which the block is moving. I don't stand on ground and decide. I stand on the surface on which the block is moving and I decide the direction of friction. So when I stand on this surface, this 2 meters per second is 1 meter per second. So velocity of B with respect to A is 1 towards right. So it is moving towards right with velocity with respect to the surface. Friction is towards left. Of course, different Fk prime. Because normal reaction is different, mu is different. All right. If surfaces are different, mu is different. Unless otherwise mentioned, if at all surface, if I just say different surface, it means different mu. All right. So do you understand why is the friction towards left here? Over here as a left. Whenever to decide friction, I will not see the velocity from the ground. I will see the velocity from the surface on which the particle is moving, on the block is moving. This block is moving on the surface, so I stand on this surface. Block B is moving on A, so I stand on A and decide direction of friction, kinetic friction. You see, we are dealing with kinetic friction. All right. Now let us say this is moving with 1 and this is moving with 2. Now I have to decide the direction of kinetic friction. So what I do, I stand on the ground. This is going towards right, so friction is towards left. Makes sense. But when I stand on this to decide the direction of friction on B, I will not stand on the ground and decide. I will stand on the surface on which the B is moving. So B is moving on A, so I stand on A and decide what is happening. When I stand on A, block B seems to go towards left or right. In which direction does the block seem to go? As
Sir,
observed.
Left.
left.
Right. That's good. Left. Left. That means if it's going towards left, my friction is towards
Right.
right. So my friction is, look at this. This friction is opposing this motion, but this friction is opposing the relative motion. So kinetic friction always opposes relative motion. If the statement someone says kinetic friction opposes motion, no, that's not complete. That's wrong. That's incomplete statement. That's a direction. It's an invalid statement. Kinetic friction opposes the relative motion between the surfaces. Relative motion is towards left. Kinetic friction is towards right. It will try to bring this particle to stop with respect to the surface. Particle left కి వెళ్తుంటే దాన్ని స్టాప్ చేయడానికి ట్రై చేస్తుంది. Particle right కి వెళ్తుంటే దానికి స్టాప్ చేయడానికి ట్రై చేస్తుంది with respect to the surface on which it is moving. So I repeat, to decide the direction of kinetic friction, I will stand on the surface on which the block is moving. Let's say I've got another block here. This is moving with 1. I've got another block which is moving with 3 meters per second here. A, B, and C, or A, B, and C. So friction on C would be, I will stand on 1, I will stand on B now. Then friction C మీద decide చేయాలంటే I will stand on the surface on which the C is moving. C దేని మీద మూవ్ అవుతుంది? B మీద మూవ్ అవుతుంది. So I'll stand on B and then I'll observe the motion of C. With respect to B, C is moving towards right. So friction will be towards left. Kinetic friction is easy to handle because my kinetic friction is mu times N times negative of relative velocity. All right. So I'll give you a scenario again. One more scenario. Then you tell me direction of friction. So we'll go for a nice problem. See, static friction is self-adjusting. Kinetic friction is not. Static friction is a little difficult to handle compared to kinetic friction. So that's why I'm dealing with kinetic friction first, then go to static friction next. So I'll give you a scenario. One meter per second, 2 meters per second, and 3 meters, 1 meter per second. A, B, and C, meter per second, meter per second, meter per second. I will decide the direction of friction on A, B, and C. All right. Give me a minute. Please try this. Think about it. Give me a minute. I will try in a minute. Yeah. Have you decided, students? Is it decided? On A direction, able to be first see the static curve. The immediate perfect curve. Direction is towards right or left?
Left, sir.
Left. Good. Yes. Left is right. So on C it is towards left. On B due to C. On B due to C.
The left, sir. Left.
Left is right. But its reaction on C. Its reaction on C is towards
Right.
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 So on A due to B.
Right, sir.
Right. Correct. Its reaction on B towards left.
Left, sir.
Right. So this is reaction. Reaction. Action. 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 Reaction on ground is towards right. All right. To find the friction on A, I will stand on the surface on which it is moving. So I'll stand on B and observe A. If A is moving towards left, friction is towards right. Its reaction on B is towards left. Friction on B is, I'll stand on C. I will not be bothered about what is happening to A and what is happening to ground. I'll stand on the surface on which the block B is moving. Block B is moving on C. So I'll stand on C and observe the particle. I observe that the particle is moving towards right because 2 meters per second is more than 1 meter per second. So friction will be towards left. Its reaction on the surface will be towards right. See, action reaction pair in Japan. The moment you think of a force, think of its reaction. If you think of a force, if you come across a force, see where this reaction is acting. That's very important in friction now. All right. That habit of immediately thinking of where the reaction force acts is very important in friction. Usually ఏమవుతుందంటే reaction force మిస్ అయిపోతుంది. Alright, అది మిస్ అయితే ఒక మొత్తం ప్రాబ్లం చేంజ్ అయిపోతుంది. Alright, whole calculations change. Any accelerations change అయిపోతాయి. So all answers change. You'll get a wrong answer. Even if your analysis is correct, it's just that because you remove the reaction pair, యాక్షన్ రియాక్షన్ పేరులో ఒకటి యాక్షన్ కన్సిడర్ చేసి రియాక్షన్ మిస్ చేస్తే you'll lose the whole problem. All right. So the moment you see a force, think of its reaction force. నేను నార్మల్ రియాక్షన్ డ్రా చేస్తే థింక్ ఆఫ్ ఇట్స్ రియాక్షన్. నేను ఎంజీ డ్రా చేస్తే థింక్ ఆఫ్ ఇట్స్ రియాక్షన్ విచ్ ఇస్ ఆన్ ఎర్త్. రైట్. కానీ సూడో ఫోర్స్ మాత్రమే రియాక్షన్ ఉండదు. ఫర్ ఎవ్రీ రియల్ ఫోర్స్ యుల్ హ్యావ్ అన్ యాక్షన్ రియాక్షన్ పేర్ ఎక్సెప్ట్ ఫర్ ద ఎనీ నాన్ రియల్ ఫోర్స్. Unreal force will not have a reaction pair which is pseudo force. Okay, now look at the students. I've got a table, horizontal table. పై నుంచి చూస్తున్నా gravity is inward. Particle is going like this with velocity v naught. So direction of kinetic friction ఏంటి? This is my horizontal table. Direction of friction ఎలా ఉంటుంది? If this is 45 degrees, direction of friction ఎలా ఉంటుంది? Go with the equation, students. Go mathematically. F is equal to mu into n minus vr cap. Look at this. Direction is decided by relative velocity and opposite direction of relative velocity. Only direction. Doesn't matter what the magnitude is. It's a vr cap over there. So it's vr, v bar is v naught is here. So velocity of this block with respect to the surface is towards in this direction at an angle of 45 degrees. So particle seems to go in this direction. So friction will act opposite to that. Fk. Alright. Velocity ఈ direction లో ఉంటే friction ఈ direction లో ఉంటుంది. Is it okay? All right. I'm unable to hear your voice. Maybe you're saying something, but I'm not getting your voice. All right. If it's okay, I'll go ahead. Now, look at this, students. Now, presume this block is moving upward with velocity v naught. So friction will be leftward, rightward, downward, upward.
Downward.
Downward.
Downward. Kinetic friction is downward. The moment the block is moving with respect to surface, I will talk only of kinetic friction. I will not talk of static friction. You will not have static friction and kinetic friction discussion together. You will either talk of static friction or kinetic friction because surfaces in contact either are at rest with respect to each other or moving with respect to each other. The moment they are moving with respect to each other, you have kinetic friction into picture and you will talk only of kinetic friction. And we are now talking only about kinetic friction. Now, students, we are coming to a very interesting question now, but follow this carefully. So friction is downward. Now, if this plank is also moving towards right with velocity v naught, now what's the direction of friction? Think carefully. Let's go slow, but let's understand this equation carefully. We are going to
Down.
solve a previous problem now. Sorry. Your voice is breaking. Is my voice clear?
Yes, sir.
All right.
Yes, sir.
Yeah, thank you. All right. Now, what is the velocity of block with respect to the plank is what I have to find out. Because for direction of kinetic friction, all I need is relative velocity direction. Once I figure out that direction, opposite to that direction is my friction, kinetic friction. So what is the relative velocity of this block with respect to this? Velocity of block plus of or minus velocity of the plank.
Oh,
So this plus of reverse velocity of the plank. So this plus this means velocity is somewhere here. So relative velocity is in this direction. VR bar is in this direction. If VR bar is in this direction, my friction will be exactly opposite to VR cap. So my
we are
FK,
cap.
FK is opposite to this direction. So this is making an angle of 45 degrees with the vertical. You all agree with this?
Yes, sir.
Yes,
Now,
sir.
now let us say it is root 3. It is V naught root 3. Now to figure out what is the direction of friction. Now what do? 1 + 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - 1 / 2 × 10⁻⁷ - I do the same thing. Velocity of this minus velocity of this. I add these two. V naught root 3 and V naught. So this angle becomes 30. So friction is now at an angle of 60 degrees below horizontal. Is it 60 or 30? Yeah, sorry, 30. So relative velocity is in this direction, making an angle of 60 degrees with the vertical. So this is 30 degrees. So friction is, but one question now, what is the magnitude of friction now and before? It is same un. Magnitude of kinetic friction is same, only direction is changed because relative velocity direction has changed. Magnitude does not depend on the relative velocity. It only depends on the relative velocity's direction. It doesn't depend on the magnitude of the relative velocity. ఇప్పుడు v naught root 3 ఇప్పుడు చూడండి ఇది v naught root 3 అయిపోయింది relative velocity చేంజ్ అయిపోయింది ఇంతకు ముందు v naught ఉంటే సో v naught root 2 was the resultant ఇప్పుడు v2 v naught is the resultant. So relative velocity magnitude has changed but direction is also changed. It magnitude is changed but my friction magnitude will not change because it is independent of the direction. It is independent of the magnitude of the velocity. It only depends on mu and normal reaction. Normal reaction in changes the change అయిపోతుంది. Surface changes the change అయిపోతుంది. How will I change normal reaction? We'll see later. So but only two factors which can change friction magnitude of friction is mu and normal reaction. ఈ రెండిట్లో ఏం చేంజ్ కాకుండా నా kinetic friction value change కాదు. Kinetic friction. Alright, I'm not talking about static friction. We are talking kinetic friction, which is given by this equation. This equation is only for kinetic friction, not for static friction. Kinetic friction is equal to mu n times minus Vr cap, where Vr bar is relative velocity of particle with respect to the surface. Okay, now look at this, students. I'm coming to the question now. I've got a block, or I'll just show it a particle, small ball, which is projected velocity v naught upwards with respect to ground. And the plank is moving towards right with velocity v naught. All right, so I'll project it somewhere here. I have to decide the direction of friction, which we have already decided. Velocity of this with respect to the plank. If I stand on the plank and observe this particle seems to go in a diagonal direction. All right, difficult to visualize, but mathematically, if you conclude and then you come back to visualization, it becomes easier. Velocity of this with respect to this plank. So velocity of particle minus velocity of plank is somewhere here, which is 45 degrees, making an angle 45 degrees is horizontal or vertical. So now velocity, relative velocity ఇలా ఉంటుంది. So friction will be in this direction. ఇప్పుడు చూడండి, friction direction and velocity direction are opposite to each other. Right? In this case, they're opposite to each other. Understand this carefully. Friction direction and velocity direction, relative velocity direction are opposite to each other. Obviously, that's what this equation says. Then what happens to the particle with respect to, so this plank will not observe this velocity. This plank will observe this velocity as v naught root 2. So this particle will seem to go diagonally like this. Diagonally వెళ్ళి ఆగిపోతుంది, రిటార్డ్ అవుతుంది పార్టికల్. ఎందుకు? Force is anti-parallel to velocity. That means acceleration and velocity are anti-parallel. If velocity and acceleration are anti-parallel, particle retards, right? With respect to the surface, this particle retards. So particle straight వెళ్ళి రిటార్డ్ అవుతున్నట్టు కనిపిస్తుంది for the plank. So for the plank, when I stand on the plank, for a person standing on the plank, this particle motion is straight line or any curved path? It's a straight line because velocity is in this direction, acceleration is anti-parallel to it. It will go on just retard, one dimension motion. Retard అవుతుంది, ఆగిపోతుంది. Alright, దాని తర్వాత ఏమవుతుంది తర్వాత మాట్లాడదాము, but retard అవుతుంది. Alright, with respect to this plank, it will go on retard. Eventually, once it stops, because it stops, VR bar is 0. friction disappears. Kinetic friction disappears. So kinetic friction ఎప్పటి వరకు ఉంటుంది? As long as there is relative motion, they will have kinetic friction. But once there is no relative motion, kinetic friction disappears. And what happens is static friction comes into picture. That will deal later. Static friction గురించి తర్వాత మాట్లాడదాం. But as long as the particle is moving with respect to the surface, kinetic friction comes into picture, and that is what we are talking about. Now, the particle is moving in this direction with respect to the plank. Force is in opposite direction, anti-parallel to it. Force anti-parallel అంటే acceleration కూడా anti-parallel because acceleration is in the direction of force. F by m, A is equal to F by m. F bar direction లోనే acceleration ఉంటుంది. That means acceleration and velocity are anti-parallel. Whenever velocity and acceleration are anti-parallel, particle retards. It's a one-dimensional motion and the particle retards. Agree with that?
Once again, sir.
Yeah. This is a very important point because next point is a little complicated. Particle is moving in this direction. Forget about the friction as of now. Particle is moving in this direction with respect to this plane. If frictionless అనుకుంటే ఇలానే వెళ్ళిపోతుంది particle, right? V0 route to వెళ్ళిపోతుంది left కి. Relative motion లో మనం చూసాం. If this velocity is actually moving upward, particle is actually moving upward with respect to ground, but with respect to plane ఎలా అవుతుంది? ఈ డైరెక్షన్ లో మూవ్ అవుతుంది. ఇది స్మూత్ అనుకుంటే స్ట్రైట్ వెళ్ళిపోతుంది. కానీ ఇది frictional surface కాకుండా ఇది frictional surface. That means there is some friction on it, and friction will be opposite to the direction of relative velocity. Relative velocity ఈ డైరెక్షన్ లో ఉంటే నా ఫ్రిక్షన్ ఈ డైరెక్షన్ లో ఉంటుంది. ఫ్రిక్షన్ ఈ డైరెక్షన్ లో ఉంటే యాక్సలరేషన్ కూడా ఈ డైరెక్షన్ లో ఉంటుంది. Because acceleration and force are in the same direction always. Force is the cause of acceleration. Force direction ఏ డైరెక్షన్ ఉంటుంది, acceleration కూడా ఆ డైరెక్షన్ లోనే ఉంటుంది. If acceleration is in this direction, A naught, velocity and acceleration are anti-parallel. ఎప్పుడైనా velocity and acceleration సేమ్ డైరెక్షన్ లో ఉంటే velocity ఇంక్రీజ్ అవుతుంది. అదే యాంటీ-ప్యారలల్ ఉంటే పార్టికల్ రిటార్డ్ అవుతుంది. You are agree with that, right?
Yes, sir.
Velocity and acceleration are anti-parallel అంటే particle retards. ఇక్కడ ఏమవుతుంది? Velocity is in this direction and acceleration is anti-parallel to it. It will go and retard and eventually stop. Why do I say stop? Because friction will bring it to rest. Kinetic friction will always try to make the particles which are moving with respect to each other, it will try to bring them to rest with respect to each other. So this particle will eventually stop in this direction. ఈ డైరెక్షన్ వెళ్ళి స్టాప్ అయిపోతుంది. ఒకవేళ ఫ్రిక్షన్ లెస్ ఉంటుండే it would have gone to infinity. But ఇది frictional surface, so acceleration is anti-parallel to this one, it will go and stop. Agreed? So it's a straight line motion.
Yes, sir.
All right, now let's go for ground reference frame. ఇది నేను ప్లాంక్ మీద నిలబడి చూశాను, ఇలా కనిపించింది నాకు, మోషన్ ఇలా కనిపించింది. అదే గ్రౌండ్ మీద నిలబడి చూద్దాము. గ్రౌండ్ మీద నిలబడి చూస్తే this is ground. What is the velocity of the particle with respect to ground? It is not V0 root 2. Rather, it is V0. You all remember, because I projected the particle velocity V0 upward. It is V0 with respect to ground, not all right. See, V0 is velocity of particle with respect to ground. So velocity ఇలా ఉంది, యాక్సెలరేషన్ ఇలా ఉంది. యాక్సెలరేషన్ సేమ్ ఈ డైరెక్షన్ లో ఉంది. ఎందుకు? నేను యాక్సెలరేషన్ ఎలా కనుక్కున్నాను? ఫోర్స్ డైరెక్షన్ లో కనుక్కున్నాను. ఫోర్స్ ఎలా కనుక్కున్నాను? కైనెటిక్ ఫ్రిక్షన్ లో కనుక్కున్నాను. కైనెటిక్ ఫ్రిక్షన్ ఎలా కనుక్కున్నాను? I stood on the surface on which the particle is moving. I told you, to find out the kinetic friction direction, I have to stand on the surface on which the particle is moving. So I stood on this plank, I found the direction of kinetic friction, which is responsible for acceleration. So acceleration ఈ direction లో ఉంది. Whether it is with respect to plank or with respect to ground, my acceleration is in this direction only. But with respect to ground, my velocity is in this direction. Look at this, the cross product is not zero now. ఇంతకు ముందు cross product was zero, they are anti-parallel. So particle was moving in a straight line. But here now they are not anti-parallel or parallel. The cross product is non-zero. This cross product of B and A is non-zero. What happens when the cross product of V and A is non-zero? We did it in projectile motion, remember? What kind of path will it take when the cross product of velocity and constant acceleration is non-zero? It will take a parabolic path. Remember?
Yes, sir. Yes.
ఇప్పుడు చూడండి ఇప్పుడు so this will take a parabolic path like this with respect to the ground with axis of the parabola parallel to A bar. Students, is it comfortable? Do you understand what I meant? With respect to Planck Tuesday, particle went in straight line. How could I say it is a straight line? Because velocity was in this direction, 45 degrees low. Acceleration was in this direction, anti-parallel to velocity. When acceleration and velocity are anti-parallel, the motion is linear and it goes in straight line, retards, particle retards. But when seen from ground, velocity is in upward direction and acceleration is in the same direction as before. యాక్సిలరేషన్ ఎలా వచ్చింది నాకు? ఫోర్స్ వస్తే యాక్సిలరేషన్ వస్తుంది. ఫోర్స్ ఎలా వచ్చింది? అది కైనెటిక్ ఫ్రిక్షన్ కాబట్టి నేను ఏ సర్ఫేస్ మీద మూవ్ అవుతుంది ఆ సర్ఫేస్ మీద నిలబడి కైనెటిక్ ఫ్రిక్షన్ తెచ్చుకుంటాను. కైనెటిక్ ఫ్రిక్షన్ తెచ్చుకోవడానికి ఐ నాట్ స్టాండ్ ఆన్ గ్రౌండ్. I will stand on the surface on which the block is moving, particle is moving. If the particle is moving on this plank, I'll stand on the plank. If the particle is moving on this ground, I'll stand on ground. If the particle is moving on some other block, I'll stand on that block to get the direction of kinetic friction. To get the kinetic friction, I will stand on the surface on which the block is moving. I will stand on the surface on which the particle is moving. ఇక్కడ నుంచి నేను kinetic friction డైరెక్షన్ తెచ్చుకున్నాను. kinetic friction డైరెక్షన్ తెచ్చుకుంటే నాకు యాక్సిలరేషన్ డైరెక్షన్ కూడా వచ్చేసింది. Acceleration direction is same whether it's with respect to plank or with respect to ground. It's a real force. Force change కావట్లేదు. Frame change అయితే. Alright. Force change కాదు. It's a independent of reference frame. It's a real force or independent of reference frame. Pseudo force depends on reference frame. But because there is no accelerated reference frame, no pseudo force here. ఇది కూడా కాన్స్టెంట్ వెలాసిటీ తో మూవ్ అవుతుంది. గ్రౌండ్ కూడా రెస్ట్ లో ఉంది. So both are inertial reference frames. So acceleration is this direction. Angle between velocity and acceleration is neither 0 nor 180. So it's going to be parabolic. So V naught cross A naught is non-zero. When this is non-zero, my path has to be parabola with axis parallel to G effective, if you remember. All right. So this is going to be parabola with respect to Planck or with respect to ground. It's a parabola. With respect to Planck, it's a straight line. So ఎలా తెచ్చుకుంటాం trajectory? For trajectories, I need velocity and acceleration. If the velocity and acceleration are parallel or anti-parallel, it's a straight line. If velocity and acceleration are not parallel or anti-parallel, that means the cross product is non-zero. It's a parabola with the axis of the parabola parallel to A bar, acceleration vector. All right. See, I did not draw the whole parabola like this, if you note. ఇలా డ్రా చేయలేదు నేను. ఇలా రావట్లేదు parabola. ఇక్కడ వరకే ఆపేసాను. That we'll discuss tomorrow or later. You think about it, why it stopped over there? You think about it, we'll discuss it later. All right, అర్థమైందా? Should I repeat the whole process again for 1 minute? We still have 2 minutes.
Yes, sir. Yes, sir.
Yeah. Should I repeat or should I go ahead?
రిపీట్ చేయండి సార్ ఒకసారి.
Repeat, sir.
Yeah. చూడండి, with respect to Planck చేద్దాం ముందు. With respect to Planck చేసినప్పుడు velocity, relative velocity direction ఈ డైరెక్షన్ లో ఉంది. V0 ఈ డైరెక్షన్ లో ఉంది. ఇంకా రిలేటివ్ వెలాసిటీ ఈ డైరెక్షన్ లో ఉంటే నా కైనెటిక్ ఫ్రిక్షన్ ఈ డైరెక్షన్ లో ఉంటుంది, FK. కైనెటిక్ ఫ్రిక్షన్ ఈ డైరెక్షన్ లో ఉంటే my acceleration will also be in this direction because force decides the direction of acceleration. Now velocity and acceleration are anti-parallel to each other. That means my cross product V0 with respect to the Planck, V0 cross A0 equal to 0. When the cross product is 0, my path has to be linear with a line parallel to A bar. So A bar ఈ డైరెక్షన్ లో వెళ్ళి పార్టికల్ ఈ డైరెక్షన్ లో వెళ్తుంది, ఇలా వెళ్ళి రిటార్డ్ అవుతుంది కాబట్టి ఆగిపోతుంది. ఆగినాక ఏమవుతుంది తర్వాత మాట్లాడదాము. సో ఇప్పుడు The particle is going in this direction, retarding, and going stops, eventually stops because particle is retarding. Why is it retarding? Because action and acceleration and velocity are anti-parallel to each other. If they were parallel somehow, they would accelerate. But velocity will always be reduced. Relative velocity will always be reduced because of kinetic friction. Kinetic friction will always reduce the relative velocity. It is a retarding force. With if I talk of relative velocity, it is always reduce the relative velocity. It will try to bring the particle to rest with respect to the surface. Relative velocity తగ్గుతుంది, decrease చేస్తుంది. All right, this is with respect to the Planck. Now, with respect to ground చూస్తే particles velocity is upward with respect to ground. So V naught direction నాకు తెలుసు, A naught direction నాకు తెలుసు, cross product is not zero. Look at this, the angle is not 180 or 0. With respect to ground, my velocity and acceleration cross product is non-zero. Why is it non-zero? Because velocity ఇలా ఉంది, acceleration ఇలా ఉంది. Acceleration ఇలానే ఎందుకు తీసుకున్నాను? ఫోర్స్ డిసైడ్ చేసింది. ఫోర్స్ ఎలా డిసైడ్ చేశాను? కైనెటిక్ ఫ్రిక్షన్ కాబట్టి ఈ సర్ఫేస్ మీద నిలబడి ఫోర్స్ తెచ్చుకున్నారు. కైనెటిక్ ఫ్రిక్షన్ తెచ్చుకోవడానికి ఎప్పుడు సర్ఫేస్ మీద నిలబడతాను. ఏ సర్ఫేస్ మీద? Surface on which the block is moving. The block is moving on this surface, so I stand on this surface, get the direction of kinetic friction. That is the direction of acceleration. So with respect to ground also, that's the direction of acceleration. Acceleration direction తెలుసు, velocity direction తెలుసు, constant acceleration ఇది. ఎందుకంటే magnitude చేంజ్ కావట్లేదు, normal reaction చేంజ్ కావట్లేదు, surface చేంజ్ కావట్లేదు. So acceleration is constant, velocity తెలుసు. Constant acceleration లో v cross a non-zero ఉంటే parabolic path ఉంటుంది, which will be parabola with axis parallel to a bar, but it will not be a complete parabola like this. All right. Is it now
Yes,
clear?
sir. Yes, sir.
Okay, the whole argument is clear, right? Why motion of the particle with respect to Planck is straight line? Planck మీద నిలబడితే straight line లో వెళ్తున్నట్టు కనిపిస్తుంది, ground మీద నిలబడితే curve లో వెళ్తున్నట్టు కనిపిస్తుంది. All right, and that curve is a parabola. Why is it a parabola? Because it's a constant acceleration motion. Constant acceleration motion లో v cross a non-zero ఉంటే it's a parabola with the axis of the parabola to parallel to a bar. All right.
Yes, sir.
All right, students. So let's stop here. We'll continue with kinetic friction and static friction tomorrow. So all your job today is to just revise whatever we have done now. All right.
Okay, sir. Okay, sir.
All right. See you then. Have a great day. Bye, everyone.